2 radical 3. It says it wants me to find. So first of all, what quadrant would that be in? First quadrant. How do you know? It's positive 2 radical 3 is the point. It asks me to find the angle that the line through that point would make with the x-axis, and the distance that point is from 0. So let's start with the angle. How can I find this angle? Good, I know it's a 90-degree triangle. Now the opposite side is 2. The adjacent side is 2 radical 3.
You drew it.
That is backwards. Thank you. I don't care. Good. I would hope you recognize this as a 30-60 triangle. If not, you could use what? Tan inverse to find the angle. But it is a 30-60-90 triangle. 1 radical 3. This would be double the smallest size of 4. Either way, I've actually answered 2 questions in one, haven't I? This would be the 60-degree angle. Does everyone agree? And it could be in radians or degrees. It didn't say. So either way you answered that is fine. And the distance at that point is from 0 would be 4. Now we knew that this one because it was a 60-90 triangle. If it weren't a 30-60-90 triangle, how would we find that side? Pythagorean theorem, right? We have x and y. We can do x squared plus y squared equals that side squared. Does this feel like something we just did with vectors? Doesn't it? Today it's going to feel a lot like vectors, but we're learning something completely different. We're learning polar coordinates. Now it feels like they're completely different, but you'll see today why we teach them at the same time, because polar coordinates and vectors have a lot of similarities in the trigonometry behind them. So let's talk about polar coordinates. Polar coordinates, two different coordinate systems. Your whole mathematical career, you have used what are called rectangular or Cartesian coordinates. You all know that? One of those 2 words. The Cartesian coordinate system or rectangular coordinate system is square. X, Y, go right and up. And the problem with that is our world rectangular. What is it? Circular or spherical. So polar coordinates work more in that for those purposes. We are only in Cal 1 and 2 and trig. We will only touch polar coordinates. And if you do go on in mathematics and take Cal 3, you will get into spherical coordinates, 3-dimensional coordinate system. But in our small world, we will stay with just polar coordinates. Got a polar coordinate system. Gives you an angle and a distance from the pole, or the distance from the center. Does that not feel a lot like a direction of magnitude? So that's why we teach these together. Polar coordinates and vectors have a lot in common. So polar coordinates is a coordinate system where they will give you an angle and a radius, an angle and an R. So say I give you an angle of 120 degrees and an R of 5. Well, how would you graph that? It would go 120 degrees, which it looks like. Here. 15's perfect, thanks. So 15's, I need to go all the way over to 120, which would be right here. Okay. So 120 degrees, 5 units out. That's how you graph using polar coordinates. Any questions so far? information we need to pick up, kind of like the vector day. We just have some information we need to know. Point P has rectangular coordinates x, y, but it can also be located with polar coordinates r, theta. So radius and the angle is how polar coordinates will be represented. The origin is called the pole in polar coordinates. Same thought process as the origin. If the radius is greater than 0, then point P lies on the terminal side of theta. The weird thing is we can actually talk about r being negative with polar coordinates. So, something new to us. Polar coordinates are going to be r, theta. And you can see the picture up here. You can imagine the three equations we're going to have that relate polar coordinates to rectangular coordinates. They're the same three equations from vectors, except instead of calling it the length of v, we're going to call it r. So you can kind of tell why we talked about these at the same time. Be ready for me to move it down a little bit. If r is less than 0, then the point lies on the side opposite the terminal side. They're directly 180 degrees opposite of the terminal side. So if I have a 30-degree angle, but r is negative, then instead of being up here, I'm going to be down in quadrant 3. So that's what a negative r does. It puts you on the other side of the pole from the terminal side of the angle. As you can imagine, there are multiple representations for every point. Unlike rectangular coordinates, x and y takes you to one spot. There's only one x and y that's going to get you there. For polar coordinates, there are infinitely many ways you can represent each point, because we could go around a circle as many times as we want with coterminal angles and whatnot. So polar coordinates can have multiple representations. This is important. If I were making a note card for this chapter, this would go on it. However, do these look familiar to you?
Yes.
And what are they?
Look at the triangle thing on the bottom left.
Here you go. Pythagorean theorem, bottom left. If I replaced r with the length of v, would those be the exact same equations for the horizontal and vertical components of a vector? Yeah. These are the way you find a horizontal and vertical component of something given with an angle and a distance, just like with vectors. You saw with vectors the triangle picture on why this works, right? We're just using trigonometry. You need to memorize these four equations. They will be important to have memorized when we get in Cal 2. Now, I use the word memorize loosely. You could draw a picture and get them back, and I'm okay with that. So we'll use the word memorize loosely. Understand / memorize. However you can get it in your brain. It's good. These four equations will take you from rectangular coordinates to polar coordinates, or from polar coordinates back to rectangular coordinates. Plot the point by hand, then find the rectangular coordinates for them. Plot the point, then find the rectangular coordinates. Notice something that is slightly different than vectors. Vectors, because they are a physics application of trigonometry, the angles are always represented in degrees because physics always uses degrees. Calculus uses radians, and so for polar coordinates that will translate calculus next year, we will use some radians with polar coordinates. There's very good reason that we use radians in calculus. We'll talk about that later. So, how do I plot two 30 degrees?
Go for 2 and go to 30 degree line.
Go to the 30-degree angle, go 2 units out. Which this one is the 30, 90 is divided into 3 parts, the 30 degree first one. So I'm going to go 2 units out. So that's how I plot the point in polar coordinates. Any questions about that? I want to know what the equivalent rectangular coordinates are, the x and y. So I would need the horizontal distance and the vertical distance. How can I find the x?
10, 30 times 10. Define the right one.
Find the,
This one.
no, what'd you say?
10, 30 times 10.
I like the 2. Okay,
30. It's like
cosine 30 would give me the x. Why cosine? Okay, let's look at the triangle for a second. If this is x and this is y, to find the x, I know this distance is 2, right? So the x would be, cosine of theta would be x over 2, or 2 cosine of theta would be x.
I did the bottom part too.
Oh, okay, so 2
Over 2.
is 2 out. What is this? What is the cosine of 30 degrees?
3 over 2.
3 over 2. So multiply that by 2 and you get this. Any questions about that one? What is the y? Good. 2 sine of 30 degrees, which is 1. Everyone agree? So the rectangular coordinates are square root of 3, 1. Does that make sense? Well, again, this one's another 30, 60, 90 triangle, so you probably could have found that without doing that work. I wanted to radical 3. See that there. Okay, negative 4, 2 pi over 3. So where is 2 pi over 3? Second quadrant. It's the 60-degree angle in the second quadrant. I'm going to go negative 4. What's that mean?
Goes in the other opposite.
So instead of being up here where I thought it was, it's down here on the other side of the pole. And how many units out? There's the point. Any questions about how I got that? So it's a little strange. We've dealt with negatives before. So it's on the other side of that. What is the cosine of 2 pi over 3?
Negative.
Negative 1/2. And let's talk about how I got that. 60-degree angle in quadrant 2, right? So cosine of the 60 is 1/2. Quadrant 2 would make it negative. And so I have negative 4 times negative 1/2. What is the sine of 2 pi over 3?
just 290.
Because that negative four is negative and all that. Pi over 3. That makes sense.
Yep, okay.
Sine of 2 pi over 3 is positive root of 3 over 2. Everyone agree? Questions about how I know that? It's the unit circle practice that right before the final, which is good. Negative 4 times root of 3 over 2 is negative 2 root of 3. Calculator. Any questions so far? Negative 4 times positive root of 3. I'm just doing the math. Now, let's check it for reasonability. Would positive 2, negative 2 root of 3 get me to that point?
Yeah.
It would, wouldn't it? Makes sense, doesn't it? Now, it didn't maybe at first, but it gets me there, so the math works out. Okay, pi over 4, negative pi over 4, which is, how do you do negative angles? Go the other way. I do need to draw an extra angle in here, don't I? Because that was 30 and negative 60, I need negative 45. 5 units out. 1, 2, 3, 4. Questions so far? X is 5 cosine of negative pi over 4. Cosine of negative pi over 4 is radical 2 over 2. Why is it positive?
Because it's going over to the right.
It's to the right. So 5 radical 2 over 2. And then y would be
5 radical 2 over 2. Negative.
5 times sine of negative pi over 4. Sine of negative pi over 4 is negative. So I get negative 5 radical 2 over 2. So my point is 5 radical 2 over 2. Any questions about that?
So what's that word problem mark should do?
The ones that we got yesterday. Oh.
Mark.
Give 3 other pairs of polar coordinates. What does that mean?
Those are just like
Right, yeah, I could add 360 as many times as I want. Now, I want to challenge you. I want one of them with a negative r.
it's not hard. Take 140 minus 360.
No, negative r.
Oh, that's minus.
Okay, so let's see if we can
Add 180.
It is telling me I had to, but okay, so of course you already mentioned the first way you can get another point is just to add 360. So 360 plus 140 is 500. So that is one other representation. Of course, I could subtract 360 like you said, and that would be 3. Negative 220.
Or negative 220. Okay, so just put a negative in front of the 3.
Now let's draw a picture to do the next part. 140 is in this quadrant, right?
Yeah.
Somewhere around. So how can I get back down to this angle?
Add or subtract 180?
Add or subtract 180. That would get me to the. Add or subtract 180, and that'll get you to the other spot. And then you can make the angle negative. So if I subtracted 180, I'd get negative 40. Right? So negative 3, negative 40 is another option. Could we go all day long if we wanted to?
Yeah.
but we're getting there. Determine two pairs of polar coordinates with rectangular coordinates -1, 1. So backwards, I want to find the polar coordinates, and I have the rectangular coordinates. I can plug them into the equation, so I can do no thought and just plug them in. Or some of you are more geometric and you can draw a picture. It's up to you how you do that. I'm going to show you both options. -1, 1's up here, right, somewhere. Everyone agree? What's the angle over there?
45.
Gotta be that 45-degree reference angle. And what would it be since it's in the second quadrant? 135 degrees. Since it's a 45 reference angle, but in the second quadrant. So, 135 degrees. And what would R be? How'd you get the square root of 2? Okay, I'm going pretty quick on this. You just did 45, 45, 90. Now, let's just think it through. Let's pretend it's not a 45, 45, 90. How do we get there? Pythagorean theorem, right? I know that x squared plus y squared equals r squared, right? So I get 2 equals r squared. So r would be plus or minus radical 2, right? You could use either one. You could use positive radical 2. You could use negative radical 2. Depends on where you put your angle. I do still have to think a little bit. Because if I do tan inverse y over x, not that it matters, but we'll do it right. 1 over -1. So tan inverse of -1. What's your calculator going to tell you? I don't think so. It tells you -45 degrees, which is perfectly reasonable. But we're going to have to know what to combine that with, right? We can either combine that with the -r and leave it as it is. So we could do negative radical 2, -45 degrees. Or, if we wanted to put it back in the quadrant, we could do 135 degrees. Remember, tan inverse is only going to give you one answer. So you will have to be able to move that quadrant. What's one other option? Oh, I only said 2. I'm done. But I got 360. Polar equation. I want to write this equation in polar format, which means instead of having x's and y's, I want r's and thetas. Okay.
We're done.
I have 4 equations that I can use, and I'm going to do substitution. What do I know x equals?
R cosine theta.
And what do I know y equals?
R sine theta.
So would you agree this is r sine of theta equals r cosine theta minus 3? Any questions about that? If I wanted to graph this in polar format in my calculator, if you will, really quick, I'm going to show you a cool trick on your calculator. Go to mode. Normally it's in function mode. What is an option that looks interesting?
Polar.
Polar. Move it over to polar. Push enter. So if we do this, it depends on what your calculator's in. You can do polar equations in radians or polar equations in degrees. Go to y equals now. What's it look like? R equals. Okay. So if I wanted to graph this in my calculator, now technically it's in polar form, but it's useless if I don't have r by itself, just kind of like it's useless in rectangular form if I don't have y by itself. Could I get r by itself? What would I need to do first?
So. Oh wait, I didn't see that.
Okay, so for doing rectangular coordinates first, when you are solving an equation for x, what's your first step always? Get all the x's on the same side. So what should I do first? Get all the r's on the same side. Then what? You've had to do this a couple of times with some big stuff.
Factor alpha.
Factor the r.
Oh.
And one more step.
Ready?
Divide. We will do more graphing tomorrow, so I'm not actually going to work on your calculator because we can talk about window and yada 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 stuff. But I can put that in my calculator. It better give me a line that looks like y equals x minus 3. Any questions about that one? Yes? Okay, what about the next one? Change it into polar form. How would that be?
R sine theta.
And divide by? Okay. Any questions about that one?
On the first one, because I'm just straight up divide by.
You could, but you would have r by itself because there's still r. Any questions about that one? Last one. Two ways to work it. Easy way and a hard way. So let me think about it for a second. See how many of you can your answer. Work it out. Either way works. Okay, not necessarily clever answers, just how would I work it?
Change the y and the x's.
Okay, so I could just change the x and the y to r cosine theta and r sine theta. Is that gonna work? Absolutely.
This is the hard way to work it.
Mm-hmm.
I mean, it only took me 3 seconds.
That's not hard. It's just easy. Factor out an r squared.
You're right.
Now I could divide by cosine squared plus sine squared. Or I could just change it to 1. Cosine squared plus sine squared is 1. So I get r squared equals 25. What is x squared plus y squared?
R squared.
See that? X squared plus y squared. Could have used that other equation. Is r squared. You know, however you want it. So what's r? 5, right? Plus or minus, technically. We'll talk about that later. R is 5. What? Anyone from Algebra 2 remember what x squared plus y squared equals 25 gives you if you graph that? Circle. In polar coordinates, r always being 5, radius always being 5, wouldn't that give you a circle? Radius 5. Makes sense.
It works if you plug in sine and cosine. Theta.
Oh, gives you a circle.
Little bitty circle.
We'll talk about those.
Yep.
Look this ground.
And you gave me air.
It's Actually, it's probably because your plot's very fun. I don't know what the errors say.
Invalid data.
Go to Zoom 6, maybe. Okay, r equals 2 sine of theta. I want to go backwards. I want to write these as rectangular coordinates.
Change it to 2y.
Okay, it definitely has a y thought, but what's it missing to be a y? What is y equal to?
R.
Equal to r, right? Wouldn't this equation be much, much easier to work if there was an r on the right? Wouldn't it be a lot easier if there was an r on the right? What can I do to equations?
R squared equals 2.
I can multiply, as long as I do it to both sides, I can multiply. So I'm gonna, I think that helped me all the way around. Would you agree? Because on the left, what's r squared? That's easy, right? And on the right, almost 2. If we had more time, I would make you review some conic sections to show you what that graph looks like. I'm going to spare you just because of time. We only have 2 days of coordinates, so I don't have time to spend reviewing conic sections at this moment. But if you subtract the 2y over it and completing a square, you can find out what that graph looks like in rectangular coordinates. But we're not going to do that today. So if you get one that's nasty to solve for, we'll leave it. R equals 5. What should I do? Square both sides.
Or.
Why is squaring both sides a good idea?
So then you can just get x and y.
Because then you just have x and y, or then you have r squared, which is just x squared plus y squared. You could also do the square root of x squared plus y squared. That way. Any questions on that? This is your homework for here first. With the worksheet, I'm also going to give you some polar grid paper. I don't remember, I think on tonight's homework in the book there's some things that have you taught. So if you want to use the polar grid paper, you're welcome to maybe having to draw a bunch of circles on your paper.